Okay, we should be live here. Hi, folks. Hey, Alan. Welcome. Get Restream up here. We're gonna work on some drone things today, just for a little bit. Streaming schedule's gonna be a lot more scattered for the next few weeks. I'm in Palo Alto. I'm taking tons of meetings, so schedule definitely gets messed up with that. But I do what I gotta do. I think we were getting kinda close to having something working. Yeah, so we had a working build of this last time. And this is just the racing task. So if I recall correctly, the score was not really being computed the way it should be. We're going to fix that. We're going to get a decent benchmark. Also, let me stop clipping my microphone. That ought to be a little quieter. We're going to get a decent benchmark on this. And then we will see if we can get one policy to do both racing and other stuff. How are we adding logs at the moment? So we add a log here and here, potentially. Okay, so we have, this doesn't get any rewards, right? It just gets this compute reward. Which honestly doesn't work super well for this, I don't think. Really doesn't work super well, right? The issue that I have here is that I'm rewarding... I have kind of two different problems, right? All of the different drone swarm problems I can cast as some form of go to this objective, don't collide. The ring ones are a little trickier. I can just add like a rings hit or something to it, right? How do I... It's gonna get messed up like instantly though. Yeah, the logging is a bit tricky. The way we do our logging, if you only have a task, like if you have different tasks and they have different metrics, that's going to be an issue. We definitely need some sort of way to tell if it's completing the course. Any way around this? Really isn't much way around this that I can see. I can definitely hack it. Yeah, let's do where's the log? Not in here? Oh, it's here, okay. So we'll just do rings. We add one ring here to rings past. And then we'll add that. Oops. Okay. So the goal here is that we actually can see the number of rings that the drone is collecting on average. Because it's not always going to full solve. Like, we're doing weird things, like we're randomizing the weight of the drone and its inertia and stuff like that. And when we do that, we can basically make it so that it's impossible to fully solve the course. This thing is not working somehow. Oops. And vlog rings past. What happened here? Okay, I broke something because it's not compiling this correctly at all. Hey, Lee. Starts learning, gets thrown off. No, it's not logging the rings at all, is the thing. Like, this score is not the number of rings collected. The thing that's difficult here, right, is that I'm trying to make one sim that can do drone swarming, it can do formations, it can go to target, and it can also race. So, like, different tasks have different log metrics that we care about, and we have to be a little bit careful about how we collect those, because, like, we want to eventually make sure that it's doing well at all the tasks, essentially. Right? We're going to want to be able to see that, hey, our drone can do all the tasks. And then basically, if we are able to do that, then we just have the ultimate policy. And that's going to be so robust in general that we will pretty much just be able to throw it on a real drone and have it do anything. If it can fly like whatever drone that we throw it, like any possible drone in simulation, then the idea is that the real world drone is one of those somewhere, right? It's in the space of the drones that you've trained. I was trying to run Puffer. Windows Docker file. Shit is stupid. Don't run it on Windows native. Run it on WSL. If you must use Windows, use WSL. I'm trying with rockets. That's awesome. Like actual rockets? Are you a physicist? Or rocket scientist? Or like hobby rockets? Because we are very interested in real world applications outside what we're working on at the moment. You probably figured out how to land some rockets, control some rockets with RL. RL rockets is a vibe. There are no vibes around here, all just code. But yeah, I mean, like a lot of these things are control problems, right? Like, I think there's a well-known paper that's doing fusion calibration, like whatever the heck it is. I don't know the technical details of fusion, obviously, but there's like some calibration problem. We have to deflect plasma like very specifically, and that was done with RL. M2 Mac. Didn't get it to fall on. Didn't get it to fall on the MPS, so it fell to CPU. Use hyperbolic. You can do either of those. Yeah, so MPS or CPU on a Mac is going to be substantially slower than an NVIDIA GPU. NVIDIA GPU on WSL or Linux will work. Otherwise, you're stuck with cloud stuff. I always suggest people in this space to just have a local machine that has decent hardware and run Linux if you can afford one. It's just dramatically easier for everyone involved. Like, honestly, just ML dev in general is not a fun thing when you can't run locally. Like, I have this problem right now because I haven't fixed all the drivers on this machine, so I have to SSH to my other box, and it's a pain. Way better just have your stuff local. Hmm. Rings past. This is weird that this doesn't... Really? This doesn't get it? Yeah. No vibes, just code. I'm a computer engineer. I love defense, man. Yeah, I mean, the drone stuff we're doing has obvious applications in that space, and we will be looking for contracts once we have some cool demos. You should not be bottlenecked by VRAM ever in RL. Unless that's a 4 gig card, but even then I think you'll be fine. 6 gigs, you're fine. Now 6 gigs is fine for RL. Cause like here, watch this. Okay, so we're doing 8192 drone M's, and we're using like 1.3 gigs of VRAM. And this is a 4x bigger model than you need most of the time. So you're totally fine. Like, technically, yes, you can OOM, like, maybe our biggest ends with our biggest possible settings, but, like, most of the time you should just be fine. So I got you covered. 4 gigs? Well, you just see that, you just saw this was using 1.3 gigs, right? This was using 1.3 gigs for what I just did. You can get stuff that will go over 4, but, like, realistically, you should be able to run a bunch of stuff. And Lee, this is like, we actually have a, there's a mode you can enable to, like, make it way more VRAM efficient even than this. This is with us not offloading anything to CPU. This is us keeping everything on the GPU. You just don't need that much VRAM for what we do. This is one of the reasons that we buy our own hardware, actually, right? Because, like, buying a $20,000 H100 that's not any faster than a 5090, it's actually slower for what we do, right? Hitting moving targets with simulated missile. Yeah, you're gonna have a way easier time just getting Pufferlib to work, man, I guarantee you. SB3 is not going to be fun. Like, you're gonna be more than 100 times slower, more likely 1,000 times slower on average. It's just a different world completely. Like, it's a completely... You'll see. Ask some of our other users. We got a cool thing. Yeah, it's not like one of those things where it's like, you know, there's Pufferlib, there's this other RL library, it's like, and they're all do about the same thing. Pufferlib is like completely different at this point. Like, there's nothing comparable. SB3 is slow as it's not even that slow compared to other stuff out there, is the thing. It's just that Puffer's that fast. Hey, welcome. Puffer wasn't working. Well, but the thing is, right? You didn't come and ask me on stream, and I haven't seen questions in the Discord. We have a super active community Discord that with helpful people, and then also I stream as many hours as I can a week. I've got a bunch of meetings over the next few weeks, but I'm still going to be getting in a decent chunk of streaming hours. So, like, it's not perfect. Most of the remaining setup issues, by the way, are literally Python packaging level stuff. It's just stuff wrong with Python that's really tough for us to work around. But yeah, we can generally help you. I spent a lot of time making it as easy as possible, and I'm here for to provide free support for the rest of the stuff. What are you talking about? Pufferlib. We do high performance reinforcement learning. That is the well, that is what we do around here. Why the heck is this thing not compiling new encode is what I want to know. Is this like just not... Maybe it's not even taking the code. Okay, so this is actually taking the new code. Set up. In place. Course. Happen in Pufferlib. Give it a try. I think that you'll be very happy once you have it set up. And, like, it's... To give you an idea of the stuff that we've gone through to try to make it easier, like, there are breaking version changes and setup tools that make everything a pain. Shipping CUDA kernels in general is a total pain. And then there are, like, multiple recent updates to Python that have, like, added extra annoying flags that we have to work around. Is this your library? Yes, it is. Hey, welcome, K. Hey, welcome, K Invert. I've seen you in the Discord. get my calendar up on the other window. It's going to be a relatively short stream today. I just want to get a couple drone things training because of meetings. Dude, how is this thing not... Okay, I don't understand why this thing is not picking up my new log variable. This is Joseph's life, pretty much. I would actually way prefer this to be what I'm doing. I've got a whole bunch of meetings to do this week, but hey, business side has to grow as well to fund everything else, right? Okay, so float rings past, right? Log rings past. I've never had this bug before. I've never had this bug where something just won't show up. Huh. Compilation bug? It does compile, right? Yeah, it compiles. Let me just do one thing to make sure. Oh, I totally misread your thing. Like, I have it in super small font on my screen. I misread that as this is Joseph's life. That's funny. Are you bet? Is it better than GPT? It's different. It's definitely different from GPT. GPT is a really big, clunky general model. These are like small superhuman models for specific tasks. Alright. Yeah, something definitely is wrong. I don't know if it's with the build process or what. Hmm. So for some reason, the new log variables are just not getting added. I mean, I guess the most productive thing for me to do will just compile it in debug mode, and then I'll be able to stick a breakpoint in here. This was one of the things that took a while to get working, but we have a debug compile mode that lets you set breakpoints in C, and then you can hit those breakpoints when you run from Python. I'll show you. So if I just do... the command is a little obnoxious, so I leave it in the top of the setup.py. You see this massive thing? And this is going to be a mess, so let me do it like this. Okay, so this is now Pufferel. Train and Puffer Drone Swarm. Right, so this runs, but now I want to actually set a breakpoint. This GTB. All right, so we do break. Is YouTube chat not showing up? It is. You see it on the screen, right? It's right there. So obnoxious, man. There's like some weird OS bug. It's some weird OS bug that like gives you a permissioning error no matter what you do. Yeah, that makes things a little more complicated. Yeah, this is just what happens when I'm like on some jank setup. You start getting bugs that you don't normally get. I'm sure this is like some weird setup related thing. Let's see if this is actually compiling anything. It should be. So this shouldn't compile because it should get an error here. And if it doesn't, then it means that it's like somehow the paths are messed up or something. This first portion will compile, that's just the CUDA. Okay, so this is getting compiled. Am I filtering the logs or something? Oh. You're right. You recommend building M's in C++? No, not at all. We like C. It's much easier. Oh, you know what? I wonder if it's just never getting set. Would that do something? If it never gets set? No, it should still show up, shouldn't it? It should show up regardless. Whatever, we'll do this. We'll see if this makes a difference. Hey, how's it going? Okay. No, I'm serious about that. Like, it's actually easier in C. Like, for the stuff that we do, it's just like pretty low level simulation work, and C++ gives you a lot of ways to just shoot yourself in the foot. That like you get penalized way more in RL for doing that type of stuff than you do in general programming, if that makes sense. This is like stuff I cover in my guide. Is stuff like, is it just not using this file? I think it's just somehow not including this file. I think it's like some jank compilation setup bug. Because otherwise this doesn't make any sense. Like, I should either be getting a compile error because I have a name wrong or something. Yeah, okay, it's not using this file. I don't understand how that's possible, but it's totally not using this file. Okay, so drone swarm. This is the correct binding. Something's mapped wrong. Can I do... Oh, god damn it. You know what it is? I know what it is. That's so obnoxious. Wonder if Spencer's doing stuff at the same time. Oh yeah, he totally is. Okay. Well, that's fine. I forgot I had Spencer also messing around on this machine. Alright. Yeah, my bad, Spencer. Okay. This was literally some dumb setup thing where we're both basically compiling our code on top of each other, and like the symlinks are getting messed up. Yay. Alright, that was really stupid. Let's actually get a little bit of stuff done today though, right? Okay, this will be +1 ring passed. Yeah, so it's basically like we were both running pip installs, I guess. And like it must just be switching the symlink. You know, like we have two versions of Puffer on this. We should just have them in separate containers, but I was lazy, so I didn't bother setting that up. So, yeah, whatever. This won't mess with anything because this is only my local install. And then I can, if as long as I run it like this, we should now actually be able to see the rings passed. And we get very, very different results. Cool. We did 5 max rings. The max score here is 5. It should be 5. Apparently not. Oh, because it's max rings passed in 512 steps, I suppose, right? Yeah, so we should probably... Do I want to do it based on time or course? Probably based on course, right? So then what I should do We'll see if that does anything. Now we full reset the env. Right, we fully reset the environment. It's ring index, not agent index, yeah. Oh no, you can't do it here. Because the agent has a ring index. Okay, so it actually does, because it's multi-agent, we actually have to do like fixed budget. Okay. So what did we get before? Nine rings pass, that's pretty good. 100 ticks, that's reasonable. This definitely works. So now we get to do all the tasks together potentially. Well, this is the swarming task first. Let's make sure this works. Okay, so this is also stable, apparently. 0 rings passed because there are no rings in the swarming task. And now, what we can do, we'll give it all tasks, but we're going to do them in a different ratio. So we'll do if this is going to be half racing tasks, half swarming tasks. So this is like dramatically different stuff we're asking the bots to do now, right? We're asking them to do a race half the time and to do like a swarming thing the other half the time. Max score here should be, rather comparable score should be like 4.5, I believe, since you only get to do a racing task half the time. Okay, so we do take a little bit of a hit to our performance, but we would expect it to take longer to train, right? So if I do something like this, I should be able to get us a nice train curve on Neptune. Yeah, and this is already randomized as well. Well, yeah, I think we'll be able to actually get, we'll be able to ship this to the drone guys pretty soon. We got a couple undergrads doing really cool drone work on Puffer, and they've been needing a better sim for a little bit. Okay, we get Nans, lovely. Yeah, that's always fun. What do we do about Nans? I think that the first order, we just suspect the learning rate gets to be too high because of the basically because of the learning rate decay schedule, you have too big of a learning rate for too long and you can destabilize things. We'll try that. Induction has a structural architecture blueprint. I have no idea what that means. Our model is mostly working though, it seems. We would like this to be like a 4.5. We'll see if we get a 4.5. I think that's what we would expect to be able to get. Fingers. What? Welcome to the stream regardless. Okay, it works. So, I should probably get this working locally so I can just render this for you guys, right? It's a little bit annoying because, like, maybe I can at least get the CPU version of the Docker working for you. Maybe that's what I can do. I'll show you the thing that's annoying locally. If I just do like this, those are some words that can go into a sentence. Where the heck am I requiring CUDA here? I guess just from the base image it knows, huh? Yeah, that's obnoxious. So I can't run this. Can I at least install it locally? Maybe I can just get the UV version, yeah? I can probably get the UV version to work real quick. Is that worth doing? Probably worth doing. This will be a fun test as well, because this is a super janky machine setup. So if Pufferlib works on this, we'll be pretty well off. So let's see, UV. Go grab UV. Do you have a point with any of this, Morgan? Yes, we are programmers. But what is the relevance? Reinforcement learning? Oh, you're trying to do like parallels to biology? There are some parallels, but the thing is we kind of don't understand everything well enough to like really draw parallels correctly. Um but at least I've found it best to just look at everything as an empirical science that's loosely biologically inspired at best. There is probably a lot to learn from biology, but it's not super easy because it's a heck of a lot harder to reason about things we don't fully understand. I mean, actually, I think that's a funny thing. It's probably harder to reason about like biological processes than it is to just do empirical science on neural nets that we also don't fully understand. Huh? No idea. All right. You're kind of just saying words at this point. Hey Shadow, how's it going? I'm trying to get the drone stuff running locally and show off some policies we just trained. So, all right, this setup is a total pain in the ass. The thing is, the reason this setup is a total pain in the ass has nothing to do with Pufferlib. Like, this is just normal ML jank with CUDA and Torch and stuff. So yeah, I'm not going to be able to make this thing. Well, to be fair, I can get the CPU version running real quick, which should be enough for evals. Let me do that. Gotta love driver jank, right? Funny how it actually doesn't give yeah, this just installs the wrong version by default. That's crazy. Hmm. Well, I don't really want to mess with this a ton on stream. So I guess I'll get this working later and we'll just do some experiments for now. What kind of end would you like to see in Pufferlib? I have some ideas in the guide that I released. I mean, the main thing that we really want that's a bit harder, I'd say, is we want we want new prototypes in different application areas where we haven't done work professionally yet, right? We want to like get this working on a ton of different problems in industry. Are you pulling with UV forces? And no, we're not. But that's not the problem. It's just dated CUDA stuff. Like this machine I haven't updated in a long time and I don't want to stall for an hour while I go mess with all that. So we'll just do some stuff on these terminals are not running locally, these are running remotely. The only thing is I never got X forwarding set up correctly with this, with our Docker containers. Like I can't actually render the policy remotely. We should probably just fix that. That'd be way better. I mean, this does work though. This is definitely working. I guess what we'll do is, since I've got to go for a meeting in a half hour, let's just get some configuration options into this. Because the idea here is that we're going to be training on a mix of racing tasks and swarming tasks. We can kind of just clean a few things up and we should already be pretty good to go. These like that. I don't like how our scoring works. Maybe we can fix that, because if we just had a better scoring function. I mean, I guess we have the collision rate as 0 and out of bounds is 0. Collision rate as actual 0 is kind of weird, isn't it? Is it 0 initially? Ah, okay, so there's a problem then if it's 0 initially. Oh, this is why. Okay, so this is 32 ends, 32 drones. See if this makes any difference. Correct me if I'm wrong, Pufferlib reaches 1 mil on Pong and policy accepts images as input? No. Yeah, no, we don't do 1 million with images. We do like, we've done up to 20 million with state though. It's not really practical to do 20 million, but we've done it. Normally we're like 4 to 5 million. I think we got Atari up to like 50,000 or something, which if you look at like CleanRL 1000 with the same network, or SP3 is also like at like 1,000, is decent. You try it with images? I mean, we did originally do stuff with Atari, right? We originally did stuff with Atari and got like 50K, but the thing is, like, why would we, right? If our goal is to advance research and to advance RL generally, like, it's always the right call to do your experiments 100x faster. Like, it's not a more interesting problem because pixels, right? It's just a slower problem. Adding a perception component really doesn't add anything to the reinforcement learning component. Okay, so this still trains nicely. I think we can't do 32 though. I think it's 64 drones is what we. It's supposed to be 16 times 64. Because like that's the number that we like the flag environments and stuff, right? They're designed for 64 agents. We could technically make it more configurable. Unlocks many other fields. Yeah, but the thing is, it'll work. Like, it's not like our stuff won't work on images. It's just slower. That's straight up it. Like, if we want to work on, okay, what if your env is slower? We're still not going to use slow envs to test that, right? What we're going to do is we're just going to change our axis that we care about to samples instead of wall clock. And we're going to just do methods research still as quickly as possible doing that. Like, there's almost no point at which you would want to use slow M's in your research loop. It'll just take longer. Yes, exactly. But, like, taking longer to train the policy means you can run fewer experiments. Right? And also that you have to physically, like, they don't parallelize infinitely. So even if you have unlimited hardware, you still have to wait between experiments. You really want your dev loop to be as quick as possible. Yeah, so this is doing well, even with the way more drones. Well, at least the racing task is doing well, but the perf task is not. We should probably do the swarm task separately, right? And get like some unified score. Well, hang on. The perf task actually. The perf task's not doing well. That could literally just be like, hey, the drones are too big and they're bumping into each other. So if I just did. If I just do this, and now I retry the swarm task. See what this does. We have M's with full state info, and once we're sure about the design, then we switch to camera. Yeah, so that's more reasonable. There's still quite a bit of research to be done in this area. We're very well positioned to do it. It's just that, like, I've been busy building out applications and such. And that's kind of the plan for the next several weeks, is to just, like, work on all these apps. I've been waiting for the live so we can talk a bit on how to integrate off-policy algorithm. Can you join on Discord? Yes, I can. I do have a meeting in, like, 20 some odd minutes, but I can definitely chat for a bit on the Discord. Okay, I will be on the voice channel. We are stealing your GAE for our own experiments. It's puffer advantage, not GAE. Did you not notice the different shadow? Hey, Mohammed. Yeah, just mute the. Okay, yeah, you're good. You just had to mute the live stream. How's it going? The off policy stuff working? Yes. I think what we have to do is you'd have to just make another file, like basically just copy paste the pufferl file and try to integrate your stuff that way. And then the main goal of the off policy stuff is not necessarily that we want to support a bunch of different algorithms. It's that we want to determine what is better, and we want to actually integrate off policy stuff into the puffer trainer if it's better, right? The goal is always to be to have like the one best algorithm, and we kind of want to steal stuff from off policy if it is useful. Mm-hmm. Oh, that's fine. Do you have training graphs and stuff, or okay? Sure. I mean, are you solving like some of the basic tasks you should be able to just solve in seconds, even on CPU? Hmm. Pong is Pong is here. Look at this. Puffer train. Okay, so this is obviously going to be fast because GPU. Uh, that yeah, that's already done. Okay, and that's a perfect solve. But we can also do train.device CPU. And I'm still getting like 300,000 steps per second here. You see? Now, this is a good CPU, but you should still get 100,000, even on like a bad CPU. Unless the off policy stuff is just like fundamentally way slower. Okay, I can look at your code then. Hang on. You have code the link? That's fine. Whatever is easiest, as long as I have something that I can actually read, you know? So we tried an off-policy buffer with just PPO and vtrace, and it didn't work. Like I think you have to change quite a lot to maybe have it work. Oh, I didn't see that you'd sent it to me. My bad. Okay. This. Oh, it auto opens in VS Code. Lovely. Hang on, let me get this thing set up. Doesn't hide the chat. Well, this is why, right here. Right, this is, I mean, this is like a tuple per element. Yeah, Python does not let you do this. This is like what SB3 does and what other libraries do. Like iterating over like this amount of iteration in Python will make everything very slow. Let's see if there's anything else that's going to be slow. Okay, yeah, basic policy is fine. And then is the last layer a Q function? Yeah, it's a Q function, right? Okay. Yeah, and then also, so this is also going to be, there are a lot of things that are just different in the way that we have stuff set up for Pufferlib, right? So this batch size is minuscule. If you check like what we typically are doing in Puffer, even for something like Pong. Well, but what auto does is it multiplies the total number of m's by the horizon. So in this case, this is like 4 m's times 1024 is 4096 times 64 is I think 260k or something. And then the mini batch even is 32,000. So it's just dramatically larger batch sizes than is normal in RL. And like the thing is, you're pretty much always going to want to do this, even if you're doing off policy, because it's sort of free. Like when your neural nets are this small, uh, you don't really get any faster by using small batches, because like you're just wasting time waiting for the data to get onto the chip anyways. Um, I would suggest doing something like that. You'll get the steps per second way faster. This would have to be like some sort of vectorized buffer. Like if you look at the way we do our experience class, it's actually very similar. Like you can probably even use the way that we have our experience class, and you can just keep it from update to update. The main thing that's different is like you need all this Q function stuff. See? And then this is original cart pull with rendering. This is not our cart pull with state. Our cart pull with state is like 10,000 times faster than this. And then you have Puffer what? Yeah, Puffer cart pull. We have it's on our website as well. Like you can see our demos. If you check, if you just kind of check here, we have them all on the website. I mean, it's not the problem is not that you don't have compute, because Puffer is actually fast enough that like you will be able to run things 1,000 times faster than whatever this is, even on CPU. Um, here. So where's cart pull? Here it is. Same environment, right? It's just not done with pixels. This will run millions of steps per second, no problem. Probably several 100,000 on CPU. Hey, Linky. Um, yeah, these DIMMs are fine. For CPU, you might like want like a 128 DIMM network. That'll be faster on CPU for you, and it'll still work. Yeah, you don't want to like. There are a lot of things that you've sort of not kept from Pufferlib that you really, really want. Like, Atom is just worse than Muon by a mile. Like, we tested this extensively. It was one of the major contributions of 3.0 was testing and realizing Muon's really good for RL. Replay memory, you are going to have to do some changes to replay memory, but like we have an experience class that is vectorized for you. I don't think it's a class, it's just in the file. We have an experience system that is vectorized for you. You just have to like keep data from update to update instead of wiping it all out. Let's see. Yeah, this type of stuff we need because here's the actual updates. Is this what you have to do? Hang on. Soft update. I actually don't recognize this. Is this from the original paper? Oh, okay. Huh. Okay. I yeah. I don't do a ton of off policy stuff, so I haven't seen this, but sure. And then here's the this is deterministic sampling, not epsilon greedy. Hmm. Yeah. I think you do need some sort of sampling because deterministic in training can be really janky. Random choice with like probability epsilon with like a specific probability. You just mean always random choice. Okay. Yeah, that doesn't work. So that only works because like the tasks are really easy. It's trivial to prove that that doesn't work as well because if you're only collecting data by taking random actions, unless your environment is very simple, you're not actually going to see most of the environment, right? Like if you just mash random buttons in a complicated environment, you're not going to get very far, so it's literally impossible to learn anything outside of the starting area. Okay, we got decay epsilon. Is this the optimizer or something? I don't know what this epsilon is. Okay. Mm-hmm. Games. Vectorized at all or no? Oh, this is not even vectorized. Yeah, of course. If you're doing one environment as well, it's going to be very slow. There's no amount of compute that will save you from this, by the way. If you do batch size 1, you can run this on like a B200 or whatever and it's still going to be slow. So, we have when here if you look at the way we do things in Puffer, right? This here is a single environment, right? So when we're doing our stuff, we have this is 1,024 environments on 4 cores. So it's a 4,096 environments total. So you're getting like a decent batch of data of like 4,000 observations at once. And that's going to be way more hardware efficient. GPUs do not work when you give them one sample at a time like that with a tiny network. You're spending all of the time just waiting on data transfer. Like I wouldn't be surprised that this literally trains faster on CPU than GPU with the way that it is here. Just because of the lack of data transfers. So if you kind of look at the things, like if you look at the way we have stuff set up by default in Puffer, and then you kind of adapt this, I think that there's possibility that off policy will work. But like, yeah, if you do it this way, it's just you're not going to be able to run experiments. And even if I give you all of my hardware to like run experiments, it's still not going to be fast. Like this will literally run at like 0.01% or less of the possible hardware utilization. And I know that this is like not uncommon. Like I've seen this type of stuff done in RL before. Um, but yeah, it's really like, and this is, I mean, the main thing with Puffer, right? Is we just made everything super fast. That's why it works. Hmm. Well, that's why they don't work. That's why, right? So like when I'm literally running hundreds of millions of observations in like seconds on one GPU, right? That's why it works. Uh, the replay buffer that we have is it's built into the PufferL trainer. This? Wait, the one from where? Which replay buffer? Oh yeah, so we have that. It's not quite the same though, because we only use that with it's on policy. So we only use it on one epoch of data and then we throw it all away. Does that make sense? So ours is still like we use it in a way that's on policy, and I actually tried to make it off policy, and all I did was I just kept some of the data in the replay buffer, like in the experience buffer from epoch to epoch. It completely broke training. You actually need to add a queue function, and you need to add some of the stuff from off policy research to even have a chance of it working. Oh, works? Wait, what did you get to work? Okay. Oh, you actually have Rainbow? Okay, this is something much more sophisticated then, because Rainbow is a heck of a lot harder to implement than this. Okay. Oh yeah, have you seen that we have prioritized replay in Pufferlib? Okay, so I can actually here. We have it in a slightly different form, but we do have it. I think you'll find this interesting. And then I gotta go soon because I got meeting to get ready for important meeting. So reprioritized experience, where is it? Puff advance. Okay, here. Right. Budget. Where the heck is it? Prioritized. I know we have it in here. Where did it go? I haven't looked at this in a while. Oh, here it is. It's just at the top of train. So here's like the annealing beta. And then here's the mini batch priority. Here are your prior weights and prior props. So this is prioritized replay applied, just inline. Okay, so this is similar. And then Rainbow has a whole bunch of fancy tricks. Cool. Huh, it actually trains. That's funny. It's cool you actually got this to train. Is this... Wait, is this... Oh, wait, is this conv... No, these are real scores, right? Yeah. Cool. It's kind of crazy you get this to train with it being this, this slow. I guess it is cart pull, but still. What I would suggest that you do is you start, like, taking a look at Puffer and how we do all our stuff super fast. Because, like, you will actually be able to make this stuff work just so much better on a ton of environments immediately if you can get that level of speed. Now, the only question, right, is like, is there stuff in off policy that is going to be better than what we're doing in on policy with PPO? And I think that there's a decent chance of it, but that's the open research question, right? All right, cool. I got to run for a meeting, so thank you for this. Thank you to all the folks on YouTube for tuning in here. I know this stream is a little bit more scattered because I've got all sorts of meetings. Now I'm here in person in California. If you're interested in my work more generally and want to help me out for free, are the repository, linked on puffer.ai. If you want to get involved with development, join the Discord. If you want to get more reinforcement learning content, like my guides for newcomers, etc., follow me on X. Thank you, folks, and I will be back maybe later tonight, but I got a bunch of meetings, so probably tomorrow. Bye.